All right, so now we're going to look at the law of sines and the law of cosines. These are both a review from geometry, so I won't go into great detail setting them up. I will restate them before we start to work with them. So the law of sines says that the ratio of the sine of an angle and the side opposite of that angle is consistent regardless of what angle we're looking at. So that means that the sine of A, the ratio of sine A over A, is going to have exactly the same value as the ratio of sine B over B, and will have exactly the same value as sine C over C. So this is a handy little law that we can use to solve triangles that are not right triangles. That's one of the great things about sines and cosine laws, is they're not required that the triangles you're working with are right triangles. So the law of cosines is a little bit trickier to remember how to write the formula, and has to be written in 3 different expressions depending on how you're labeling or what you're looking for in the triangle. So when we build it, suppose you're looking for the length of side A. You're going to start by writing what appears to be a Pythagorean theorem. So a squared equals b squared plus c squared. But notice there's no requirement that a be the hypotenuse. So it's not the Pythagorean theorem, it just looks like it, and that's a handy way to remember the law. So I'm looking for a squared equals b squared plus c squared. Presumably I know b and c, the measures of b and c, and I'm going to subtract 2 times the 2 side lengths I know, BC, times the cosine of the angle opposite the side length I'm looking for. So this is the first expression of the law of cosines. The second would be if I'm looking for b squared, then I would take the square, the sum of the squares of the sides I know, and presumably I know a squared plus c squared, subtract 2 times each of those sides, times the cosine of the angle opposite the side I'm looking for. And so c squared, being my third version of the law of cosines, is b squared plus a squared. Probably could have written that in the opposite order, but doesn't matter. Addition is commutative. So that's 2 times ab times the cosine of c. So these are the law of sines, or all 3 of the laws of sines, and these are the laws of cosines. All right, so let's solve a couple triangles using our laws. Suppose I have a triangle RST, and I'm given that R equals 35, S equals 22, and T equals 25. So I'm going to sketch it out real quick. I'm going to sketch it pretty big so I can work with it. 35 is my greatest value, so I know that's the hypotenuse. And then let's say S is 22, and then T is 25. So clearly not a right triangle. But between the law of sines and cosines, I should be able to solve the entire triangle. So first, let's find an angle. If I want to find angle, let's give these values or letter labelings. Let's call this angle A, angle B, and angle C. And I'm looking for angle A. Well, I can't obviously use any of the law of sines because I don't have any angle measures in my given information. But I do have all 3 side lengths, but the law of cosines is designed to give me side lengths and I already have them. But luckily, I also have to have the cosine of an angle in each of my expressions of the law of cosines. So I'm just going to solve one, and in this case, just because of labeling, I'm going to choose the first one. So I'm going to start with a squared equals b squared plus c squared minus 2bc times the cosine of a. Since the cosine of a is the thing I'm looking for, I'm going to rewrite this formula as the cosine of a equals, well, a squared minus b squared minus c squared plus, oh no, not plus, once I've subtracted b and c away, now I have multiplication connecting to cos A. So I'm going to divide by negative 2bc. Now I can plug in my values. So the cosine of A equals 22 squared minus 25 squared minus 35 squared. All divided by negative 2 times b is 25, c is 35. Dun, da, da, da. So this is just pluggy-chuggy math. I did it on the calculator. If you want to pause the video and see what I did, I just pluggy-chuggy. Plug it in, chug away. In the end, I had cos -1, or the inverse cos of the value I got, equals 38.6845. We were told to round to the nearest degree in this problem, and so I can say that for angle A, I'm looking at 39 degrees. Now, most of the time, once you've solved something with the law of cosines 1, you can follow up with the law of sines, and so I'm going to do that. So I can tell, first off, I can start with the sine of A, sine of 39 over 22, is equal to, now I have to decide, do I want to do C or B? And you have to be careful here. It's a good idea not to use the angle across from the hypotenuse. And the reason for that is it's going to be greater than 90 degrees. And when you do your calculations, it's possible to get either an erroneous or an undefined answer. So stick to your non-hypotenuse opposite angle. So this case will be B. So I'm going to take sine of 39 over 22 is equal to the sine of B over 25. Which means that the sine of B is 25 times the sine of 39 over 22, which equals 0.715. And then, if I take the inverse sine, or the sine inverse of 0.715, it tells me that the angle is 45.6544. I already know I want to round, so let's say 46 degrees. So then to find the last angle measure, I have 180 minus 39 minus 46 degrees equals 95 degrees. And so angle measure C is 95 degrees. And if you were to put into your calculator the sine inverse, the inverse sine of 95 degrees, you would get some response like error. Mine reads domain error. And so down here, when I was making the point, when you want to apply the law of sines and when you want to apply the law of sines, try to avoid using the angle across from the hypotenuse. And I think I'll not do another example. This is pretty much pluggy-chuggy math. Your time would be better spent practicing than listening to me go over another one.